Hey everyone, today we're going to be talking about Azure SQL Elastic Pools. Whenever you go out to the Azure portal to provision a brand new Azure SQL database, there are many options that you have to choose from. You have to choose from the resource group. You have to choose from the region where you want your database to be in. You have to choose the compute tier, the service tier. There are backup options, networking options, authentication options, and many more. Within the actual compute tiers, we have to choose whether we would like to go with the DTU model or the vCore model. There's pros and cons to each of these two models. Regardless of which option we choose, the main goal should be to ensure that we provision enough resources to meet our workload demands. For certain workloads, the usage requirements may be very well known and very well stable. And in those particular use cases, it's very easy for us to provision enough resources to meet that actual workload demand. For other workloads, we may not know the actual workload demand, or the workloads may spike from hour to hour, from day to day. So how do we account for these type of workloads? We don't want to over provision our resources, because then we would end up not utilizing our resources, and that would just be a waste of money for us. At the same time, we don't want to under provision our resources, because then our applications would suffer. So what can we do in this particular use case? Well, one option may be to utilize the serverless model. The serverless model allows you to choose a minimum number of vCores and a maximum number of vCores. And then based on the workload needs, your databases will auto scale up or down to meet that actual workload need. The scaling process will always stay within the minimum and maximum vCore range that you choose. However, this option is only available within the general purpose vCore model. So what happens if for your particular workloads, you only need to utilize the DTU model? Or what if your applications require you to have the fastest IO and you need to opt for the business critical model? What do you do in these particular use cases? Well, this is where Elastic Pools can come into play. So what are Elastic Pools? Elastic Pools provide you with a cost-efficient way for you to manage and scale multiple databases that may have an unpredictable usage pattern. Elastic Pools allow you to share your compute resources with multiple databases, allowing you to make the most efficient use of your resources while minimizing waste. Elastic Pools may also be a good use case for SaaS type of applications, because it will allow you to manage resources and costs for a collective group of databases. When utilizing Elastic Pools, you will no longer have a per database charge. Instead, you will have one charge for your Elastic Pool, and then your databases will consume resources from that actual pool. So let's take a real quick look at a fictional company here, just to see how Elastic Pools can help us. Our fictional company here, let's call it T's Fitness Company. And T's Fitness Company is an online retailer that sells fitness equipment. Our e-commerce web app consists of a back end, which consists of multiple Azure SQL databases. So let's just say that we have one database for marketing. We have one database for inventory. We have one database for purchase history and purchase orders, and so on. And let's say that for each of our databases, we have them configured to each utilize the DTU model, utilizing the standard S3 tier. This is going to give them each 100 DTUs. Now, let's take a quick look at the DTU utilization for our marketing database. As we can see from the chart here, our marketing database is currently allocated to have 100 DTUs. But looking at the chart here, we can see that we are rarely utilizing the DTUs that we have allocated here. We have some spikes here where we get up to 50 DTUs, and we even see some spikes here where we actually get up to 90 DTUs. But for the most part, our database is sitting idle. During these idle times, we still have to pay for compute power, even though we are not utilizing it. This unused capacity represents a waste of resources, thus a waste of money. This money could be better utilized investing it in other areas and opportunities to improve our applications and to drive in newer business. So we just took a quick look at the utilization for our marketing database, but we have many other databases that have this same type of usage pattern here. Sometimes we see some spikes that may be tied to a marketing campaign that we're doing right now, or maybe we see some spikes that may be tied to holiday sales. But with all of our databases, we have these periods where we see idle times where the database is not being used. All of this unused capacity adds up over time and drives up additional cost for resources that we are being billed for, but we are not utilizing. Elastic Pools can help to mitigate this issue. Let's assume that now we have one Elastic Pool that is provisioned with 100 DTUs, or eDTUs as they are referred to for Elastic Pools. Elastic DTUs, aka eDTUs. So now our Elastic Pool can now be utilized by 4 different databases that may each have a unpredictable usage pattern. So let's take our 4 databases and let's now put them inside of our Elastic Pool, and then let's see how things look now. So looking at the chart here, now we can see that we are getting a much better utilization here. At every 5-minute interval here, we can see that we are utilizing a minimum of 50 DTUs here. The few spikes that we see here never spike over the 90 DTU mark. So what this chart can tell us is that we are utilizing more than half of the resources that we have allocated at all times, but we never get to that point where our workloads need more compute power than what we have provisioned. So this looks much better than the previous chart that we looked at where we had 100 DTUs allocated to one database only. Using a Elastic Pool and allowing our resources to be shared with multiple databases provides us with better cost efficiencies. The cost for 100 eDTUs as part of a Elastic Pool will cost you just a little bit more than having 100 DTUs allocated to one database. But that cost of 100 eDTUs for our Elastic Pool is definitely going to be much less than if we had to allocate 100 DTUs for multiple different databases. So now let's take this example here and go even further. So looking at this chart here, we can now see that our Elastic Pool now contains 20 databases. The black line here represents the total number of DTUs that we are utilizing at any given time. As you can see, we are consistently utilizing 60 DTUs here, and we do have some moments here where we actually spike up to utilizing 100 DTUs. Remember, our main objective here is to ensure that we have enough capacity to meet our workload demands while minimizing the actual waste of resources. Using Elastic Pools allows you to share your resources with multiple databases. This is a great way for improving your efficiencies when it comes to resource management and cost management. So now we can see how Elastic Pools can help us to scale our workloads and to ensure that we can meet our actual workload demands while minimizing the actual waste. So are you utilizing Elastic Pools right now? Do you plan to actually start to utilize them now that you have watched this video here? Well, let me know in the comments section, and before you guys leave, don't forget to hit that like button and subscribe to my channel. Until next time, guys, peace.